Hello, my name is Mark Scurrell and I'm a Program Manager in the Azure Compute Group. In this session we're going to take a look at the Azure Batch service. We're going to see how it can be used to perform some large-scale compute in Azure. Now for the first part of this session I'm going to run through just a few slides, maybe take the first third of the session and provide an outline and an overview of some of the main capabilities of Azure Batch. We'll have a look at the features, some of the main features and functionality. We'll also take a look at the scenarios for which we've targeted Azure Batch. And then we'll also look at some real-world use cases, some of the really cool ways our customers have used Azure Batch and put it to use in the real world. But then really 2/3 or most of this session I really hope to spend with demos. I've got a couple of demos for you to show Azure Batch actually in use. And I'm pretty excited about some of these demos because we've got some cool new features that have basically just arrived, just appeared in Azure Batch, and I get to show you those. So let's get started. So first of all, one slide on what does Azure Batch do? And really what we want to do is provide a platform service for developers to allow you to both easily and efficiently run applications in parallel and at scale in Azure. Now there's really sort of two main areas of functionality that we provide to achieve that. So the first is you need the compute resources, the VMs, on which to run these applications in parallel and at scale. So in Azure Batch we have a concept called the Batch Pool. And really a pool is simply a collection of nodes or VMs. So there could be a few VMs in an Azure pool, there could be tens, there could be hundreds, but in some cases we actually work with customers who use tens of thousands of VMs with Azure Batch. And we can sort of move on, but I think it's pretty cool to step back and think about that sort of power and that sort of scale. I mean, sort of 10,000 VMs, that's a lot of VMs, and then especially if you multiply up by the cores on those VMs, I mean, that's a ton of capacity basically at your fingertips that you can leverage and really get that capacity really in more than a few minutes, perform your work at such a massive scale, and then when you finish, basically hand it back. So, huge opportunity and huge flexibility with Azure and then Azure Batch for the scale with the pools. So as well as getting those VMs, it's very important that I mentioned at the start, we allow you to efficiently use those and efficiently utilize those VMs and really maximize your usage and the money you're paying for those VMs. So we make it easy for you to scale up and down the number of VMs in a pool according to the load. You can do that manually, literally with a single API call, or you can have that happen for you automatically with an auto-scale feature that's built into Azure Batch. So every few minutes, a formula is evaluated and the number of VMs can either be raised, kept the same, or lowered according to the formula that you specify. And then finally, obviously, you've got the flexibility around the type of VM that you use, the VM family, the number of cores, the disk space, the processor speed, and so on, and really pick the right VM size for your application to give you the right performance. In some cases, you might want the maximum amount of performance that your users expect. So give you that flexibility as well. So that's the first set of capabilities, is all around the pools and getting those VMs to perform the work. So second then is the actual work itself, getting that work done. And that's really where we have the concept of jobs and tasks. So the task really is the fundamental unit of execution for Batch. And I always really just like to explain tasks in terms of just think of it as a command line. And I think that's really sort of the beauty, is really the simplicity. There's no special SDK that you need to convert your application to run with Batch. If you have an application, a console application or any application that can run by executing it on the command line, then Azure Batch can execute it, that it can run that application across thousands and thousands of VMs at the same time. So really sort of very simple. That sort of means, executables, batch files, PowerShells, scripts, and so on can be run. And therefore it means that a lot of existing applications are run using Azure Batch. They haven't been built for Azure. They just run on desktops, run on workstations, but now you can run them on thousands of VMs in Azure. Or sometimes new applications are written, and they can simply be written as a console application, and Batch can run it. So we provide with Batch basically the job scheduling, the ability to submit lots and lots of these tasks. Batch will queue them until there are free VMs, and then when there are VMs available, we'll assign the task to run on the VMs. Now we also have some more advanced capabilities. Tasks can sometimes freeze or hang for some reason, or there can be a transient failure. So in those cases, we have more advanced features to detect frozen tasks, to automatically retry failed tasks, and so on, to really cater for some of those situations. So really, key point here, really, bring an application, develop any application. That application can run for any length of time. It could be a few seconds up to several hours, tens of hours even. And you can run some, the existing applications unchanged. And then the price. Azure Batch, there is no charge for Azure Batch itself. The main charge for Batch would be the compute VMs that you request in the pools. But then there also may be some, networking costs, storage costs if you're using storage, and some of the other services in Azure. But for Batch itself, there is no additional charge on top of that base platform. So what should you use Azure Batch for? I think there's a wide range of scenarios where it can be applied. There's a lot of the computationally intensive applications that often need to be run at scale. Transcoding and rendering, great examples there. Rendering in particular, I think, is a great example of a workload that can be split up into lots and lots of individual pieces. The individual frames, even tiles within a frame can be separated out into individual tasks. And therefore, you can really massively parallelize that workload. And really, the scale is really only limited by the number of VMs that you throw at the problem. Image analysis and processing, file processing, another set of examples. Dev test scenarios, both builds and test execution. Test execution in particular, we really see people leveraging the value of being able to get this lot of resources when required, when test passes are run, for example, and being able to take test passes and runs that take maybe a couple of days currently and compress that and run them in a couple of hours using Azure Batch and the cloud. And then we've got the scenarios that are more the scientific, traditional HPC applications, things like genomics, fluid dynamics, and so on there. So on the other side, on the right-hand side of the slide here, we've got the some of the real-world use cases, some of the really cool ways that our customers have used Azure Batch, and a huge variety there in terms of pricing models, both for utilities, gas and electricity, as well as in the travel industry. A lot of predictive modeling, simulations and so on in the finance and insurance space, Monte Carlo simulations, unit testing I mentioned, transcoding as well. We'll see some of that shortly. Image processing, very cool processing of medical images to help diagnose illnesses and diseases, very, very quickly, leveraging the power of the cloud and the scale out. And then rendering, I mentioned as well, using Blender or Arnold or other renderers. So some really, really cool ways customers have been using Azure Batch and really leveraging the power of cloud and the scale. So there's really, for all those scenarios and particular use cases, there's really a common usage pattern. Really sort of drives our design and capabilities that we've added to Azure Batch. So it already starts with the applications. What applications do you want to run? There might be one application. In this case, it's the transcoding. And that application might require installation, or it may be simply an Xcopy onto the VM. But you need to get the application or applications onto the VM. You've then got the tasks. I'm going to transcode maybe hundreds of thousands of times per day, with different source material, different output resolutions, different bit rates, and so on there. So I'm going to have many, many tasks that are going to use that transcoding application, and they're each going to have different parameters, both input, output, and other parameters. So first need the pool and the VMs on which to install and run those applications, and then get the applications onto those VMs before they can be used. And then you've got the tasks. The applications are there, and the tasks need to be assigned. So you need to find a free VM. If it's not doing anything, then it can be assigned a task, and that task can run. If all the VMs are full, then we can queue up the tasks, wait for VMs to free up, and then assign tasks take them off the queue and assign them to the free VM. Now, most of the time, I would say, in a lot of cases, these tasks can be completely independent. They don't communicate to one another. And they might certainly use, say, common data, common files, common data from some sort of storage system. But, the actual tasks themselves don't communicate, and they can operate independently. And therefore, gives you a huge amount of flexibility to scale this out on vast numbers of VMs. But there definitely are some applications, I'd say more on the scientific side, where these tasks actually do need to be able to communicate. So we need to have a system and design Azure Batch to cater for both cases, both independent and those tightly coupled tasks. And then they actually get to run that task on the VM. There is, you're going to run your application. You're going to specify the specific, parameters for that particular run of that application. And it's normally going to take some input, and perform the run, and produce some output. Now, the input can come from, probably in a lot of cases, comes from Azure Storage, come from SQL, can come from any storage system, and the same for the output. With Azure Batch, we want to sort of really not limit you on where the data can come from and be placed. So that's sort of totally under the control of you, the developer. So there's another common usage pattern as well, and we really sort of see people with varying workloads. Now, there could be ongoing workload, but maybe at certain times of the day. There's peaks in that workload, and then troughs maybe in the evening or night and so on. But there's some sort of load, and you need to be able to increase or decrease the number of VMs, update the capacity to match the load. As I say, one of our goals is to allow you to maximize the utilization of your compute resources. So I'm sure you don't want to have VMs sitting around doing nothing. So we want to cater for this varying workload. And sometimes this can be extreme. Sometimes there can be nothing happen for most of the day, literally no cores required, no workload getting run. And then at a certain time of day, a few thousand cores, several thousand cores might be required for several hours, run the workload, and then stop and shut those down back to zero for, the next few hours until the next day. So we see that's pretty common, and really we want to allow you to get those VMs when they're needed, pay for their use just when you need them, and then give them back, and then not pay. And you can really leverage the per-minute billing for Azure Compute. So Azure Batch, where does it fit in the stack? So we have our compute platform, cloud services, virtual machines, and if you're building, your own service or solution on top of that, you certainly can cater for these sorts of workloads by building that directly on top of the compute stack. But it is a significant amount of work, and really it's just pure infrastructure. And it can start off smaller and be a manageable amount of work, but as you scale up in terms of VMs, as you scale up in terms of jobs and tasks and the work that needs to be done, what we tend to find is that infrastructure sort of tends not to scale that well, or needs ongoing and continual investment so that it's good enough and satisfy your needs. So really, it's really just infrastructure and plumbing, if you like. So that's really where we want Azure Batch to come in, to really provide that VM management and that job scheduling as this platform service for you. And you avoid building that infrastructure and maintaining it and enhancing it over time. So that's what we've got for the intro side. And let's now take a look at a demo. And in this demo, we're going to perform some optical character recognition. So let me get to my desktop. So I'm actually going to start this demo, maybe quite strangely, but we're going to start off in storage. Because, so I want to show you what files we're using as input for this application. So here I've got a storage account. I've got a Storage Explorer and I've got a storage account. And in the root of that storage account, I have three containers. So the main one I want to check out is the input container. And we can see here we've got a bunch of PDFs. And these are scanned white papers. In fact, let me select one and bring one up so you can see that it's a scanned in white paper. So we can see that we've got a bunch of old white papers. So we've got that, and what we want to do, we've got a lot of files here. We've actually got 82 files in this container, and we want to perform optical character recognition on them and produce text files as the result. So that's where my input's going to come from. I've got an output container. Refresh it, that is empty. So we can see this is where I'm going to place the text files that are the output of the optical character recognition application. And then there's the resource container, and this contains, shows you, I really just put this here to show you the files that we want to copy onto the VM. Now for this demo, I'm actually not going to use this resource container. I just wanted to show you the files, and the main files that I think are of interest. Tesseract is the OCR algorithm or application that we're going to use. And the actual task itself is going to execute this OCR task.ps1, this PowerShell script, because we're actually going to call 3 individual applications. The first one to split the PDF up into different pages, then to perform the OCR, and then to stitch it back together into one text file. So I just wanted to show you these files, but we're not going to use these files in this container, but they're going to get installed onto the VM, and I'll show you how that happens in a few minutes. So let's just go into the output there, and we'll check back there later. Okay, so next is the first thing we need to run this OCR application at scale is some VMs and an Azure Batch pool. So I am going to bring up here the Batch Explorer application. Now we provide this as a sample on GitHub. We give you the source code, you can build it and run it, and I really recommend this. Immensely useful tool for you, certainly when you're developing and testing Azure Batch. Really gives a nice graphical interface without having to write code. So if we have a look at this, we can see I'm on the Pools tab, and I've got one pool here. So I said a pool is a group of VMs, and we've got some basic information here about that pool. We've got the ID, so effectively the name, and the name in this case, OCR pool. It's active, and it's got 100 VMs in it currently. And here's the VM size. So this is fairly small, 1 core VM, standard D1, V2. And on the right here, you can see I've got the VMs in the pool, and there's 100 of these. So I just got this pool ready so we don't wait 5 or so minutes to get these VMs. It's sitting there ready. And if we have selected a VM here and we look at the Files tab, we can see that some of these files that I referenced earlier on are going to be here. So there's a lot of files, but let me see. There we go. So tesseract.exe, OCR task.ps1, for example, is installed on this VM. And we'll have a look in a minute or two at how that got installed on the VM via Azure Batch. So I've got my input files. I've got my pool with 100 VMs ready to go. I'm going to invoke one more thing here. I'm going to show the heat map. So the heat map is a really nice way during pool allocation or you're running a job to be able to see graphically what's happening. So I'm going to set the refresh time down and take here. So we can see again, it just provides a nice summary. We've got 100 nodes. If I hover over these nodes, they're all sitting idle, just waiting for work to do. So let me run some work, and I've got basically a test application here. It's a test web application, a demo service. And what we're going to do, I'm going to click the Process Input Files button, and we'll breakpoint into the code, and I'll actually show you the code that we've used to submit the job and the code that we've used to create this pool in the first place. So I'm going to hit the Process Input Files button, and here we go. So we've breakpoint here. Let me make that a little bigger. So we're in the Submit click, Job Submit. So the first thing that we're going to do in the code, and just really wanted to show you the high level, some of the API usage and how relatively small amount of code is required with Azure Batch. So the first thing we're going to do is create a job, which effectively is the container for all the tasks. And sort of two main pieces of information for the job. The first is the ID. We've got a unique ID for the job. And then the second is the job needs to know which pool it should run on or its tasks should run on. So we have that assigned here with the pool information, and we have the pool ID, which is currently set to OCR pool. So this is the first thing we're going to do is basically commit that and create basically a job object. And then, yep. So let me continue. So the next thing that we need to do is create some tasks. Nothing's going to happen until we actually create some tasks, the main unit of execution. So here we're building up a task list. And adding a task, and we're going to add one task. We scroll up here, we're adding one task for each blob that's in that input container I showed you. So we've got that input container, there's 82 files in there, and we're going to loop through each of those files and create a task so that we can have a task per file, and if we've got enough VMs, which we should do, execute all these OCR applications in parallel. So the next thing, big thing we need to do is then on the task is we have the ID, and then we need a command line. So we build up a command line string here using environment variable that says where is this application being placed, and then the file that we want to run. In this case, it's a PowerShell script. So I want to run a PowerShell script, but obviously for each task I need to customize the parameters. Here's the particular input, and here's the particular output and where the output goes. So that's what this code here does, is build this up into one command line string using PowerShell and so on there. And then the final thing to highlight before the task is added is the resource files. So we're really leveraging a feature here that allows you to specify a list of one or more files that are sitting in Azure storage as blobs. And you can specify those files and then how they're named on the local VM. And then when the task is scheduled and before it's run, Batch will copy that file from storage onto the VM, and then we can process it. So that's what the resource files are all about. So let me turn that off as a breakpoint and continue. So we're going to do that 82 times, I think. And we've got a breakpoint here where we're adding this together, where we're adding all the tasks to the job, and this is going to perform a bulk add. So I'm going to continue there. So we should see a job created in the UI here, and if we go to the heat map, we should see the heat map light up, and there we go. So if you notice here on this queued tasks little graphic, there's a small spike, literally probably for a second or so, where the tasks were queued. And then, certainly within around about a second or so, those tasks are assigned to the free VMs. And in this case, we obviously have 100 VMs, 82 tasks, so there are a few VMs that are idle, but 82 VMs are now running, and we're processing all those files in parallel on this Azure Batch pool. So while that processes, I want to loop back and show you some of the code. And in particular, I want to show you the code that we use to create that pool. So I'm particularly keen to show that because I want to demonstrate a very new feature, a pretty new feature that we recently added to Azure Batch. So the first thing you could see here is we're going to create a pool object with the create pool method. And a pool gets an ID, the name, the OCR task. We set the OS family, just as you can do for worker roles in Azure. And we've got the VM size here. This is the number of VMs. I set that to 3. And then I resized it up to 100 afterwards. But initially, I created it with 3 VMs. So the rest of the code here then, so that basically gets us the VMs. But then I need to get the applications on there. And then so the new feature I'm using here is what we call application packages. So with the application package separately, and I'll show you this in the portal in a second, I can zip up a package of all the files, zip it, and then upload it via the portal to an associated storage account, and then name it. And then here on the pool, I've got application package references, and I can set that to the list. So here I've got a list of one application package. I called it OCR, and it's version 1. So that's all I basically need to do. And then when the pool's created and those VMs are created, Batch will look and say, okay, there's an application to install here. It'll copy the zip down onto each of the VMs and then unzip it in a well-known location that we can reference with the add task. And that's what there's actually an environment variable there on the add task I used to be able to reference the OCR PowerShell script. So that's how a pool was created. So we had that. We set the mouse tasks to 1 and then committed that pool. And then within a few minutes, that pool is available. So that's how the pool got there. So let's go back and we can see we've got 1. Oh, there we go, down to 0. We've processed all those PDFs. Let's have a look. Close that, and let's go back to our Storage Explorer, and we're there on the output folder. If I refresh that, we can see we now got a container full of text files, and I can invoke one of those text files, and we can see the text that the OCR algorithm has recognized and converted. So there we go, done a bunch of OCR in literally a few minutes on quite a reasonable number of VMs using Azure Batch. So some of the components that we've used for that, moving parts. Actually, I missed the portal. Let me just show you the portal for the app packages. So this is the Azure portal. And then I've got my batch account here, shortcut to my batch account. Now I've got the essentials or summary for my batch account. And then beneath it here, we can see I can get at my jobs. I can get at the pools. But I can also get, these are the applications that I've uploaded, the application packages that I've uploaded and associated with my account. I can select that and again see that application package, and I can even go in and show you what's required when you add a new one. And the main thing I wanted to show here was, you need to enter an application ID, maybe a version, it's version 1, but the key thing here is the application package and the upload. You hit the upload button, pick your zip file, and then it will upload to an associated storage account. So really, really super simple and manageable way to package your applications, manage those applications, and get them installed on the pool VMs. All right, I'm glad I remembered that. So we looked at the portal. There was PowerShell, I haven't shown that, but obviously we have PowerShell for Batch, and I showed you Batch Explorer. And again, really recommend everyone uses Batch Explorer, certainly initially for trying out the service and for dev test even. I showed you our .NET Client API. There's also a management API for manipulating accounts and actually uploading and managing app packages as well. And then all of that sits on top of the Azure Batch service, which has a REST API, and it itself, we leverage cloud services, and that's how we get the, with worker roles, that's how we get the pool VMs that we've seen. And then with standard Windows images, and then we install the applications on top. So what I'm excited about, and we'll move to the next demo, is we've recently made available Linux. So they really allow you to use Azure Batch and create pools with Linux VMs in addition to the Windows VMs. So for that, we're using the Azure Scale Sets offering, and we build on top of that. And so actually, as well as Linux, it really allows you, when you create your pool, you can select your number of VMs and so on, and you can select then images from the Azure Marketplace, the sort of gallery images. And they can be Linux, and we certainly want to allow Linux applications to use Azure Batch and to be run on Batch and at scale in Azure, but also Windows images as well from that Marketplace. So we also wanted to provide you more choice in terms of the client APIs. So in addition to .NET, we made available a Java client API and then a Python client API. And then either we've released or will shortly release, I think it is, the Linux command line as well. So to provide that choice for basically a command line interface. So really sort of excited with this. I think it really opens up a whole lot of applications that run on Linux, and then you've got that extra choice. You've got that full choice on the programming language and the API that you use. So let's actually do a demo and let's show Linux. So actually for this demo, we're going to run FFmpeg in Linux VMs, Ubuntu VMs. So let's minimize everything, and I'll follow the script from the last demo, and we'll start off in storage. I mean, what are we going to process? So you can see it's exactly the same as the previous demo. We have input container, output container, and resource. In the input container, we have a bunch of MP4s. So these are MP4s taken from channel 9, and they uploaded them to storage as blobs. If I pick, let me pick the smallest one here. Just download that and show it. So what we're going to do with this video, you can see this is a conference keynote. And what we're going to do on this video is apply a watermark. So let me close that down. We've got the output container, that's empty. We'll come back to that. And then in the resource container, we've got one PNG file here. So this is our watermark file. And let me just open that so you can see what's going to be applied to the video. So we can see we're going to put a nice Microsoft logo right in the middle of the video there. And we're going to use FFmpeg. So let me go to the output folder and we'll check back there later. So next up, let's bring up the pools. So I've got another instance of Batch Explorer here. Refresh that. So here we've got one pool, and it's the, I've called it Linux FFmpeg. And we've got a smaller number of VMs, but slightly larger number of VMs. I've only got 6 videos here we're going to transcode, so I just created a pool with 6 VMs. We can see here on the right there's the basic information of the pool details, and in particular I sort of really wanted to point out here, this is where the virtual machine configuration can be seen. So we can see here we're configured Ubuntu server and what version of it, and then here's the VM size that we've picked for that. We've got 6 nodes, and here's the TVMs, just like the previous demo. And we can pick those VMs, and we can see we've got some files in the applications installed on these VMs. So I've got my input files, I've got my pool ready to go. I'm going to invoke again the heat map so we can easily see what's happening. So let me change the refresh interval for that. So we can see that. Now I need an application to kick off this work, create the job and the tasks and so on. So I'm going to do that from another Linux VM that I've got in Azure. So I've got the VM here. I'm in a bin folder, and I've got a demo Python script. We'll have a look at this in a second. But I've got a demo Python script there that's going to let me kick off a job, create the tasks, submit it to this pool, and then wait for the job to finish. So I've got that in my history. There we go. So we're going to run demo job to Linux. This is the Linux FFmpeg pool, and we'll kick that off. So what we see, the job should have been submitted, and then what we'll see very shortly, there we go, straight away. On the next refresh, we've now got all these VMs, Linux VMs, executing. Now actually what I also have here is a VM. I've got logged in to one of these VMs, and I can run a top. So the thing here before it finishes is you can see FFmpeg running and consuming basically all of the CPU. So you can see we have FFmpeg. It was installed on these VMs, submitted the job and the tasks for it filled up all the VMs in the pool, and FFmpeg's working hard to basically transcode and apply that watermark to the video. So this will just take a few minutes to run. It'll probably even finish in the next few seconds. But while that's finishing, I just want to show you the code. So we've got a client here, and it's a Python client. So this really sort of shows we've got a Python client API, and show you the same sort of code I showed you previously in C#, but now in Python. So the first thing down here is the pool, create pool. And we create the pool with the arguments. We want a pool ID, the number of VMs, the size of the VM. We set up the pool. Now, one difference here is we use something called a start task. A pool can have an optional start task. So this is, again, it's a task, so it's just a command line. And that is run when that VM is created. So in this case, what we've done is we actually, when the VM's created, we actually pull down Docker onto the VM. And that's what this command line does. And then we can see here the specification for the VM image. So we've done that, and then we call client.pool.add for that new pool. So very similar. Obviously, it's Python equivalent to what we saw previously. And then for the job is very similar as well. Sorry, here we go, demo job. So it takes the pool ID, we create a job ID with a standard naming convention, includes a timestamp. Now the one difference here is we have something called a job preparation task. So again, it's just a task, just like a regular task, just like a start task. But what this means is the first time a job runs, a task for a job runs on a VM, the first time the job preparation task is run. And in this case, what we're doing is we're using Docker to pull in the FFmpeg image for us and get it on the VM. Now, once it's done that once, effectively it's cached. So that's why FFmpeg started very quickly in this, because I'd previously run this and it was in the cache. But if it wasn't, it would just go to Docker and pull that image down. And then similar to the last demo, we have a for loop, and we go around and add, we go and add tasks in this for loop, one for each video. So I think there's 6 in this case. And then we wait for the task to complete. So there we go. That's our an example of a client application with our new Python API. So it looks like if we go down to the command line, this is finished. Wait for task to complete. It's done. And we go back to the heat map, and that's done. That's idle. So let's go to Storage Explorer here, and we've got our output. So let's refresh that, and great, we've got our videos. This time they're in AVI format. And I'll open the smallest one again, so we can actually see hopefully that watermark has been applied to the video. And there we go. So I can freeze that, and we can see the watermark applied. So here, just to recap, we've used Azure Pool. We've configured it with Ubuntu VMs. We've effectively initialized those VMs with a Pool start task with Docker this time to get Docker installed on them. And then when the jobs run for the first time, we pull in the FFmpeg image, FFmpeg files and what we need to run the transcoding, and then actually run FFmpeg for each of those video files. And in a few minutes, we've got them all transcoded. So that's that demo. If we go, let's just go back, last few slides in the deck. So a little bit about our Linux offering. It's initially a preview offering, but it will be in all regions and all VM sizes. What you'll find initially is that it'll be limited to certain distros, but we'll, as quickly as possible, expand that out to all the distributions that are in the Azure Marketplace. So that'll just be temporary. And we'll also expand to sort of the Windows images as well. And also we'll still support, effectively the existing standard Windows images. I showed you actually in the first demo. And then, as I said, we have the Java and Python SDK, Linux command line, and so on. We do have a few other capabilities. We added Windows MPI recently, it was right at the end of last year, for these tightly coupled tasks that need to communicate. I showed you the application packages, really make it super simple and easy to upload those packages or zips of the files that need to be on a VM, and make it easy to upload them and get them installed on the Pool VMs. Task dependencies, another feature, much requested feature, which allows tasks to be added as part of a job, but some tasks can be dependent on others, and so will not start until others have finished. So we've built that in to Azure Batch tasks. And then on an ongoing basis, we rev every week or two, we add functionality to the portal, and we want to get that very rich in the functionality and similar sort of functionality that's in the Batch Explorer application that I showed you. So just to wrap up, here's just a few links. The main Batch documentation page with overview, tutorials, articles, samples, and then our forum, where I'd love to hear your questions, hear your feedback, and so on. So that's about it for me. Thank you very much for listening, sticking with us to the end. Really hope you enjoy playing with Azure Batch and really scaling out your compute and running applications in parallel at massive scale using Batch. Thank you.